Hello and welcome back to Nunley Math. I'm your host, Aaron Nunley. Thank you so much for joining us here today as we examine the last of the 7 functions I expect my Algebra 1 students to be familiar with in my class. Remember, our goal here is to introduce the 7 functions and talk a little bit about their domain and range and some special features that are unique to different types of graph. In the next unit or two, we're going to begin to dive into those more deeply and talk about how being familiar with the shape of each graph can be useful for us as we begin to graph various varieties of these or different variations of the functions that are given. You will notice that today's function is f of x equals the square root of x. Because of that, we often refer to this as a square root function or a radical function. Just like before, I'm not given a domain, so I'm going to select values of x. I'm going to plug them into this function and see what comes out. And then hopefully when I graph those over here on a coordinate plane, I'll begin to see some things that are interesting or unique. I'm going to start off with 0. F of x equals the square root of 0. I should say f of 0 equals the square root of 0 gives me a 0. So I graph 0, 0. Since I'm putting numbers under the square root sign, I'm going to try and pick numbers that have perfect square roots. For example, f of 1 is the square root of 1, which is 1. But if I were to plug in a 2, the square root of 2 would be difficult to find, as would the square root of 3. The square root of 4, f of 4, is one that I can do pretty easily, 4, 2. Square root of 5 would be difficult. Any idea what the next one that's a perfect square would be? Hopefully you realize that's a 9. And I get 9, 3. Let's graph 4, 2. And let's graph 9, 3. The next one, of course, would be 16, which gives me a 4. 16, comma 4 is not actually on the graph. It's 11, 12, 13, 14. That's about somewhere out here. And hopefully you can begin to see what that graph is doing. Now, I do want to make special mention of the fact that if I tried to use f of negative 1, I would have to use the square root of negative 1, which is undefined. Remember, major rule here, x cannot be a negative number. X cannot be a negative number because you can't square root a negative. You can't square root a negative. Now, sometimes you can have a negative number under here depending on what else is under here with it, but it is important that regardless of what's under here, you can never take the square root of a negative number. Go ahead and put a star next to this circle. This is an extremely important rule. We're going to come back to this over and over again. By the way, this does apply to negative 2 as well. F of negative 2 equals square root of negative 2 is undefined. Negative 3, negative 4. No negative number is going to be able to go under the radical in this particular function. So I am going to go ahead and connect these and draw my graph. I'll go ahead and point out to you that there are lots of fractional or decimal solutions in here, so that if I wanted to have a dot at 6, all I would need to do is put 6 into the function and find the square root of 6. That is a irrational number. It's a non-ending, non-repeating decimal, but certainly with a calculator or enough time I could calculate that. It is going to be a value something like this, 2.5-ish. But I intentionally avoided those so we wouldn't have to talk about the computations. Notice that my graph starts here and nothing can be graphed before it. This is a vertex at the point 0, 0. In this particular graph, 0, 0 is also the x-intercept because it's where we cross the x-axis. It's also the y-intercept because it's where we cross the y-axis. Notice that my graph comes up forever. It also goes to the right forever. If I'm looking at my domain or which x's will work, I can use any x I want as long as that x meets certain conditions. In this case, x starts at 0 and continues to the right forever. All x as long as x is greater than or equal to 0. all x as long as x is greater than or equal to 0, would be my domain. Remember, if x is a negative number, I end up taking the square root of a negative, which is impossible. My range is where I go up and down, so it's all f of x's, or any value can work as long as it meets a certain set of criteria. In this case, if I'm looking just up and down, we'll notice that our graph starts at 0, and it does go up. I can see it go up to 1, up to 2, up to 3, up to 4. It is going to continue going up and up at a ever decreasing rate, but it does go up forever. So f of x is also greater than or equal to 0. Notice that it does start at 0, 0. My f of x cannot be a negative because x could not be a negative. If I don't put a negative in, I'm not getting a negative out in this particular example. In our other examples, you'll remember we looked for lines of symmetry. This does not have any lines of symmetry, nor does it have rotational symmetry either. So one of the key features of this graph is it does not have a whole lot of interesting key features. Hopefully this has been useful to you or helpful to you. Remember, this is just a quick introduction to the shape of graphs or of our functions when we graph them. In this case, we do have this funny looking curve here. Remember that every radical or square root function will always make a curve kind of like this. Now, sometimes that curve will be steeper, sometimes it will be less steep, sometimes I can write a function so that it goes backwards, sometimes I can have it go upside down, sometimes I can have it go upside down and backwards. But every square root function will make this shape in some form. Hopefully that's been helpful to you. If it has, please leave me a comment in the comment section so that I know you're watching. Also, make sure you like and subscribe and turn on your notifications so you can follow along with us as we continue our discussion of functions. In our next lesson, we will try and tie all of these together. We'll go back and refresh what we've learned and see if we can't find faster ways to graph these than just filling in tables. As always, we appreciate you watching. Take care of yourselves. Best of luck. Goodbye.